Hello guys, welcome to a new video. In this video we are going to lab. We always lab. We lab every day, guys. So what we are going to configure is we are going to configure zone-based firewalling on this South Carolina router that we have right here. We're going to have our inside network right here, our outside network. We are also going to configure DHCP on this South Carolina router. We are going to configure DHCP snooping and also dynamic ARP inspection on this switch right here. And then we are going to move on to this North Carolina and this New York City router, and we are going to configure a site-to-site with a pre-shared key, site-to-site VPN with a pre-shared key, and we are going to configure this TACAX server so we can configure TACAX so we could be able to remote in into any of these routers by using this TACAX server. So let's go ahead and start with this configuration. That's going to take a while. So Um, if you have GNS3, you can go ahead and create a topology like I have right here. And I have configured all the IP addresses, so we do not have to do that boring part of configuring a IP address for those routers and switches and all of that. So we have configured all of that, and we also configure static routes, so all of them are able to reach each other. So with that being said, um, what I want to do is I want to go ahead and start with this South Carolina, and the first thing that we want to do is let me start this switch as well. And on this switch, the first thing I want to do, let's go ahead and move this to the left side so we can see everything better from over here or from the command line. There we go. So we have more space. All right, so let's go ahead and start with this configuration. Let's go ahead into config T. The first thing that I want to do is I want to disable some things like trunking. I want to make everything as an access, as a mode access. Um, For every interface, I want to shut down the interfaces that I'm not going to be using and configure the DHCP snooping and dynamic ARP inspection as well. So let's go ahead and do that. I want to see what I have. So do show IP interface brief so I can see all my interfaces. And as you can see, all the interfaces are up and running. So what we want to do is I want to go to interface range, and I want to go to the range of 0, 0 all the way to 3, and then gigabit 1, 0 all the way to 3, and then gigabit 2, 0 all the way to 3, and gigabit 3, 0 all the way to 3. The first thing I want to do is shut everything down. Now that I know shut down with a shutdown command, there we go. So everything, all these interfaces are now shut down. So one other thing that I want to do, I want to configure all of them into access, switch port, access into VLAN, and it's going to be VLAN 1, and then switch port, no negotiate, I want to turn on. So that it's looking good. We can also configure port security, but we're not going to go into that right now. Um, so let's go ahead. Actually, we can configure switch port security, right? Port security, and I want to do a maximum of, let's see how many MAC addresses I want to allow. 1, 2, 3, 4, 5, 6, 7. Let's configure a maximum of 10 interfaces. Let's go ahead and do another port security, and we can do a violation, and I want to do shutdown. Or actually restrict, that's good. Let's see what else we can do. Um, mm, that should be good for now. Let's just leave it like this. So now let's go ahead into and configure IP, DHCP, or actually let's first configure a VLAN one interface with an IP address of 192.168.1.2/24. No shutdown. so we can communicate with the router. So that is done. Now let's go ahead into interface, or not into interface range. We first need to configure or enable DHCP IP DHCP snooping, and it's going to be, oops, I'm into the interfaces. Let's go ahead and exit IP DHCP snooping, and then IP ARP inspection, and I want to do it on VLAN 1. After that is configured, then we have to go into interface range, and we need to go into gigabit 01, 01, 00, and 02 to interface gigabit 00 all the way to 02. Let's see, oop, at the interface again. Oop, there we go. And from here, what we want to do is do an IP DHCP snooping. I want to trust these interfaces because I'm using it. IP ARP inspection, trust as well. And let's do a node shutdown since we're going to be using it. There we go. That's good. You can just go ahead and save our configuration. We are done with this switch. So we are done configuring the switch. Great. So the switch is done, has been configured. Now I want to go into the South Carolina switch or router. And from here, I want to do a IP DHCP excluded address. And I want to exclude 192.168.1.1 all the way to 192.168.1.2. Then IP DHCP. And I want to do pool. It's going to be called inside network, and we are going to configure the network of 192.168.1.0 all the way to /24. You can do the default router. If you want to do a DNS server, you can do that as well. Now let's go ahead and get into these two computers over here, and let's do a IP DHCP so we can get a DHCP. Also, we can get an IP address from the DHCP server. There we go. We have an IP address from the DHCP server. Now let's go ahead and try to ping 192.168, or actually 172. Let's ping 172.16.1.2, which is the TACAC server over here. There we go. We have connection. And now let's go ahead and do it from here as well. And we have connection. So it is working. We got a IP address from the DHCP server. The switch is performing DHCP snooping and also dynamic ARP inspection, and it is working like a charm. So we have connection and it's good. So now the other thing that I want to do is I want to configure zone-based firewall or ZBF, which what it does is it turns your router into a firewall because it's going to inspect traffic from the outside interface into the inside interface, because that's how I'm going to tell it. So the first thing that we need to create is a class map, and the class map is what classifies or identify the traffic. So let's go ahead and do that. Class maps, actually all together, class map, type inspect, and we're going to do a match. Let's see, match, type inspect match. I don't know how to spell match. Here we go, match any, and we're going to call this my class map on capital letters. That's good. After we do that, we wanted to match ICMP packets or match protocols ICMP packets, and that's all I want to allow between the anything that comes from the inside to the outside to the outside to the inside. That's all I want to allow. So it's going to inspect ICMPs. That's what I'm classifying the traffic, just to allow ICMP. Then after that, we need to configure the policy. And what the policy does is the policy map calls on a specific class map, which is going to be this one, my class map. And also what it's going to do is going to create an action of what we want to do with that traffic, with that ICMP traffic of that class map. So let's go ahead and do policy map. The type is going to be to inspect, and it's going to be called my policy map. And inside over here, we need to add the class map that we have created, and it's class type inspect, and we want to inspect my class map. There it is. And from over here, we're going to tell it what to do. We want to inspect. Great. Let's go ahead and exit out of here. And after we do that, we need to go ahead and configure or create the security zones. So we're going to create the security zone for the inside and for the outside, and then we're going to assign it to the interfaces later. So zone security inside, exit, zone security outside. And now after we do that, we need to pair the outside and the inside um, zone pair. So we need to create a zone pair, and you do zone pair security, and we're going to call it in to out. So inside to the outside, and the source is going to be the inside, and the destination is going to be the outside. There we go. And then after we do that, we need to do the service policy, and the service policy is going to be a type inspect, and it's going to inspect my policy map. There we go. So that has been configured. So now let's go ahead and put those zones into the interfaces. So gigabit 00 is going to have it's going to be a zone member of the security inside. We can add a description. This interface belongs to the inside zone. And then we can go into gigabit 01, which is the outside, and we can do it just like that, outside. We can also add a description. We can just say belongs to the outside zone and exit. So that has been done. So we have configured zone-based firewall, which is the stateful firewalling. So whenever I ping from the outside, ping, oh, let's do the same ping again. It should allow that traffic to come back in. But if we go into the South Carolina and we go into, let's see if we can get, no, we cannot get that far. So if we go into this policy map, copy, just so you can see it, and we do a no match protocol, ICMP. Mm, oh, because I'm into the policy map. It's the class map that we need to go into. Uh, so class map type, inspect, this one right here, paste it right here, and do no match protocol, ICMP. So now if we ping, we cannot get a reply because it is blocking it since we set on that South Carolina to do not match this ICMP protocol. But if we do match protocol, ICMP, we should be able to get that ping again. There we go. So now it is working. So that's how zone-based firewall works. So if you have a good router with a lot of potential, and if you are a small business and you don't have the money to get a firewall, what you can do is you can turn your router into a firewall and you can save money like that. So since that has been configured, one of the things that we can do now, let's go ahead and implement the site-to-site um, VPN with a pre-share key. So what we want to do is we're gonna have to go into this North Carolina and this New York City um, routers. So let's go ahead and configure the New York City first. So the first thing that I need to do is you need to create an access list. And in this access list, we're going to tell what traffic we want to permit. So IP access list, and it's going to be an extended access list. So you can give it extended, and the name is going to be, I'm just going to call it to North Carolina, right? Because it's from New York City to North Carolina. There we go. And over here, I want to permit the IP of 172.16.1.0, which is the source. And the destination is going to be 192.168.1.0. There we go. After we do that, we need to go ahead and create the transform set. So you do it like this, crypto, transform, or crypto. Let's see if I remember crypto. It's crypto IPsec and crypto IPsec transform set. And we're going to give it a name of strong. And we're going to use the authentication is going to be ESP SHA with HMAC. And the encryption is going to be ESP AES 256. And we're going to use the mode. It's going to be tunnel mode. Okay, and then after we do that, we need to, sorry for that, we need to go ahead and combine the access list that we have created and also add the transform set that we have created and add the peer IP address, which is going to be the IP address of North Carolina, which is 30.1.1.2. So let's go ahead and do that configuration, which is crypto map. This crypto map is going to be called NYC. Let's see, NYC2 and C. That's what we're going to call it. It's going to be 1 IPsec ISKMP. Okay, and then we need to set the transform set to strong, which was the name that we gave it, strong. And then we need to set the peer IP address, which is 30.1.1.2. And then we need to add the access list, which is match address to North Carolina. I believe that was the name of the extended access list, as you can see right here. So to North Carolina. And then we are done with that crypto map. And after we create the map, we need to create a key, and then we need to create a policy. So let's go ahead and create that key. Go ahead and exit, and we do a crypto key. And the crypto, actually crypto, I say KMP key, and the key is going to be Cisco 123, which needs to match also in the North Carolina router, otherwise it's not going to work. And the address is going to be the peer IP address 30.1.1.2. Done. Now we need to go ahead and create that policy. Crypto SKMP policy. We're going to use policy 1. And what we are going to use to authenticate is going to be a pre-share key. The encryption is AES 256. And the SHA or the hash is going to be SHA. The group number is going to be Duffield Hellman group number 2. And the live time is going to be the maximum, which is 86, which is going to be 86,400. So let's go ahead and do that, 86,400. And there it is. So after we do that, we need to go ahead into interface gigabit 02, which is the IP, which is the interface going into the North Carolina router. And over here, what we need to do is we need to go ahead and add that crypto map. So if we do crypto map, we need to add that crypto map that we created. And we call that crypto map New York City to North Carolina. Paste it right here. There we go. You can just give it another shutdown just in case it is down. Exit. Just end it. Let's just go ahead and save it. So now we need to do the same on the North Carolina. So config T, IP access list is going to be extended. So it's going to be to New York City. and it's going to have to permit an IP address of 192.168.1.0, which is the source, and the destination is going to be 172.16.1.0. Done. After that, we need to go ahead and create a the crypto IPsec transform set, and it's going to have a ESP SHA with HMAC. Let's see if I missed something. Um, crypto transform set, and then we got to give it a name, and we're going to give it the same name as the other one, strong, then ESP SHA with HMAC, which is the same as the other one. They all need to match, and then ESP AES, which is the encryption. 256 mode is going to be tunnel, and then exit. We have to create a crypto map, and after we create that crypto map, we have to call that map, and we're going to call this map New York City or North Carolina to New York City. And after we do that, we need to call this sequence, which is 1. Then is it okay? After that, we need to do an IPsec to ISKMP, and then we need to set the transform set, which was set to strong. We're going to set the peer, which is now is going to be 30.1.1.1. Then we are going to match the address, and for that address we are going to match that extended access list that we created, paste it to New York City, and let's see if we have done everything. Set transform set, the peer, and the access list. So that has been done. After that, we need to create the key and the policy. So crypto ISKMP key, and now we need to give it a key, and it's going to be Cisco 123, the same as the other one. Otherwise, it is not going to work. The address, which is 30.1.1.1. Done. Now we need to create that crypto. Is it crypto policy? Yeah, the crypto policy, but it's um, crypto ISKMP policy 1, and the authentication that we're going to be using, pre-share key, and this needs to match the other one, pre-share key, encryption, AES 256, group number 2, the hash is going to be SHA, and the lifetime is going to be the maximum, which is 86,400. Let's see if I have everything. We have authentication, encryption, hash, group number, and lifetime. So we got all of that configured. That's good. Now let's go ahead and apply to interface gigabit/2. And we need to do a crypto map, and we need to add that map that we created, which was, what is it? There we go, map, North Carolina to New York City. And let's go ahead and just do another shutdown. End it, and let's go ahead and save our configuration. So after we do that, what we need to do is we need to do a debug, and I want to debug crypto engine packet. Let's turn that on. So now from this Windows device, let's go ahead and go into this Windows device. And from the Windows device, I want to ping the TACAC server, which is 172.16.1.2. So let's go ahead into the Windows device over here. Looks like he was falling asleep. Let's turn this bad boy on. Let's go into CMD. And if we do a pin, it should encrypt everything that goes from this Windows device all the way into the TACAC server, which is 172.16.1.2. And as you can see, we are sending it and it is getting there, but it looks like it is not encrypting it for some reason. So crypto engine packet debugging is on. Let's go ahead and do a show run. Let's see what I missed. So hostname North Carolina. So crypto ISKMP, policy 1, encryption AES 256, authentication pressure key, group number 2, crypto key Cisco 123. That IP address is 30.1.1.1. The transform set is strong, ESP AES 256, ESP SHA HMAC. Mode is tunnel. So let's go ahead and compare that to the New York City one. So run. So policy 1, 256, pretty sure key, group number 2. Is the group number the same? Group number 2, yep. Then I put crypto, ISN key, Cisco 123, address 30.1.1.1. This one is 30.1.1.2. Then crypto IPsec strong, transform set strong, ESP AES 256, ESP HMAC, mode tunnel. So this one right here, we set the peer, we set the transform set and the access list. So that's good to New York City and to North Carolina. And we added this to crypto map, New York City to, North Carolina to New York City. Let's see if it is the same. Yep, North Carolina to New York City. Let's take a look over here. North Carolina to New York City. And let's see if this matches the address. Yep, 30.1.1.2, 30.1.1.2, because this one is 30.1.1.1. This one is 30.1.1.2, 30.1.1.1, and 30.1.1.1. But for some reason, it is just not working. Let's see if what do we have? IP route, a default route. Why is this a default route to? Let's go ahead and delete this default route. Um, Let me see this default route. And we also have this route over here, 30.1.1.1, 30.1.1.1, 30.1.1. Let's see if this default route is messing around. Let's see no. IP route over here. And let's save it. Let's see if we ping again. And nothing is happening. Let's do a debug crypto engine packet from the New York City as well. So we're getting a reply and it's going to send it to this one over here. Permit 172.16. This is New York City. That is correct. That is correct. And to North Carolina. Did we add to North Carolina? Yep, that's correct. Let's go ahead over here. Let's go ahead and ping again. It is pinging and we do not get, so it is not encrypting anything. And one way that you can see is by doing a show crypto engine or show crypto IPsec SA active or just SA. And you can see that it is not encapsulating or decapsulating anything. Diffie Hellman group number set to none. And this is for gigabit 02. Let's go ahead and do the same on the New York City router. See what's going on, see if we can find anything. It says Diffie Hellman group none. Let's take a look at group number is 2 and group number is 2. Authentication pre-share key Cisco 123. Cisco 123. Mode is tunnel. Let's do a, from the Windows device, I want to do a trace search and do 172.16.1.2. Let's see where it's going to take us. Should take me to the, let me, can you go ahead and cancel that? Is it tracer or trace route? Trace route. Yep, it is trace search. Let's see if we ping. Let's see if we ping it from 192.168.192.168.2.0. Or the 2.2. Okay, so I think I know what I was doing. I think it is working now. Let's see. So I'm trying to ping that 2.2 and it is pinging that 2.2. So what am I pinging when I, okay. I think it's the access list. I messed up the access list. So if we go into, let's see which one is the one that I messed up. So the access list, this one is to be 192.168.2.0. That's what it is. Config T, paste, and let's just go ahead and remove this one right here. I remember what I did wrong. And now we're not gonna have time to configure TACX. We can do that on another video. Let's just go ahead and do no. This one right here, and let's do permit IP 192.168.2.0 255. There it is. Let's go ahead and take a look at this one as well, because I believe this one is 1.0. There we go. This one is 2. Yeah, so I put the incorrect access list. So what it was blocking it, it was going into the firewall, or it was allowing into the firewall. So let's go ahead and, where is it? Let's go ahead and do no, and then we do permit IP 172.16.1.0 255 192.168.2.0. There it is, and let's save it. Let's go ahead and also end it and save it. So now let's go ahead and bring this any other routers up because they're doing debug. So now if we ping this, there we go. Now it is encrypting, as you can see right here. So we figured out what was going on. We were not, or we set up the permit access list to go into 192.168.1.0 network instead of 192.168.2.0 network. And as you can see right here, the traffic is being encrypted. And it's also doing it over here. It is encrypting and decrypting the packet. So now if we do a show crypto IPsec SA, you can see that it has encapsulated 20 packets and also decapsulated 20 packets. And if we do the same over here, you should get the same. It has encrypted 20 packets and decrypted 20 packets as well. Nothing has failed. decompress 0, failed to decompress 0. So it is working the way we wanted it. So I figured out what was wrong with it. Thank God it didn't take me that long, but it did take a little bit. And now I won't have time to configure TACAC, so I'm going to leave that for another video, guys. So hopefully you enjoyed this video and hopefully you enjoyed the troubleshooting as well. And if you guys enjoy my videos, just go ahead and follow me on Twitter at CCNA Daily Test, where I post all my videos and a lot of questions on the CCNA, CCNA Security, CCNP, and also CCNP Security exams. So go ahead and follow me on Twitter. So thank you guys for watching. I love you guys, and I'll see you in the next one. Bye bye.